Question number 39. In which one of the following type of molecules the dipole moment is non-zero? In other words, the question is regarding polarity of the molecule, which is polar and which is non-polar. We have to find out. Here A represents central atom and B represents surrounding atom or bonded atom. L represents lone pair on the central atom. Look at the options. Option 1 is Ab2L2. Ab2L2 can be written like this. It has two bond pairs and two lone pairs. So, it has an angular shape. So, it has to be polar, non-zero dipole moment. Second option is Ab2L3. This has central atom A, two bond pairs, and then it has three lone pairs. So, you can expect it to have TBP geometry with lone pairs occupying equatorial position. And that is the reason why it is linear, and because it is linear, its dipole moment is 0. And then number 3 is Ab4L2. This is expected to have the 4 B's lying in the same plane, and then the lone pairs are present one above and one below the plane. It has octahedral geometry, and the 4 B's are present in the same plane, and lone pairs are present one above and one below, and because of this square planar shape, mu equals to 0. The fourth option is Ab4. Obviously, this is tetrahedral. It is a regular tetrahedron because there is no lone pair. So, mu equals to 0. So, the correct answer is first option, Ab2 with the two lone pairs, because this has angular shape. Because of angular shape, its dipole moment is non-zero. Question number 40. Which one of the following compounds has least melting point? Least melting point. Now, the first option is PbCl2, plumbous chloride. Second option is tannic chloride. Third option is NaCl, and fourth option is AlCl3. Now, we need to decide this on the basis of Fajan's rules, which says that as the charge on the ions increases, covalent nature increases, ionic nature decreases, and as the ionic nature decreases, melting point also decreases. So, if you look at the options, you realize that the most covalent among them is tannic chloride due to plus 4 state of tin, and because it is most covalent, its melting point is least. So, the correct answer is tannic chloride. Question number 41. The d orbitals which are not involved in the hybridization of central atom in ICl4 are: first option dz square and dx square minus y square. Second option dx square minus y square dxy dyz dzx. Third option dz square dxy dyz dzx, and fourth option is dxy dyz and dzx. The question, I will read it once again. Which are not the d orbitals which are not involved in the hybridization of central atom ICl4 minus, not involved. First of all, we need to find out the hybridization of ICl4 minus. You need to calculate number of electron pairs, that is equal to half. V is 7, M is 4, and you need to add 1 because of negative charge. So, P comes out to be, M is 4 because there are 4 surrounding atoms, and P comes out to be 6. So, the hybridization is sp3d2. In sp3d2 hybridization, the two d orbitals which are involved are dx square minus y square and dz square orbital. These are the orbitals which are involved. So, obviously, those which are not involved must be dxy, dyz and dzx. These are the d orbitals which are not involved in the hybridization, because these are involved. So, the correct answer has to be fourth option, that is dxy, dyz and dzx. Question number 42. Dipole moment is shown by, now compound A is 1,4-dichlorobenzene, compound B is cis 1,2-dichloroethene, compound C is trans 1,2-dichloroethene, compound D is trans 1,2-dichloropentuene, and the options given are: first option is AB, second option is BC, third option is CD, and fourth option is BD. Let's try to find out. Look at the structures, then once you look at the structures, you will realize which is expected to have dipole moment 0 or non-zero. First of all, you have first option is 1,4-dichlorobenzene. Compound A, 1,4-dichlorobenzene. Here, the two chlorines are at 180 degrees dihedral angle, they cancel out each other. This is expected to have 0 dipole moment. So, this is not showing dipole moment, that means the dipole moment of this compound will be 0. Now, B, this is cis 1,2-dichloroethene. Both the chlorines are cis with respect to each other. So, mu is not equal to 0 here, it is a polar molecule. And then option C is trans 1,2-dichloroethene. Here the two chlorines are trans with respect to each other and they cancel out each other. These two cancel out each other and mu equals to 0. And then option D is trans 1,2-dichloropentuene. Trans 1,2-dichloropentuene. We need to add one more chlorine, and that chlorine will appear here. First carbon, second, third, fourth, fifth carbon. So, you can see it is a 1,2-dichloropentuene, pentuene because the double bond is between 2 and 3. So, this is expected to have non-zero dipole moment. There is no cancelling here, unlike these two cases. So, the correct answer is BD, that is fourth option. Question number 43. In which of the following changes bond order decreases? A is CO to CO plus, B N2 to N2 plus, C H2 to H2 plus, and D H2 to H2 minus. Let's look at these changes. CO becomes CO plus. This is possible due to loss of electron. Bond order of CO is 3 because it is a 14 electron system, its bond order is 3. Bond order of this is also taken as 3. The reason is when you remove electron from CO, this electron comes from non-bonding orbital, non-bonding molecular orbital. So, when electron is added or removed from non-bonding molecular orbital, there won't be any change in the bond order. So, here the bond order almost remains same. Now, look at the next case, N2 to N2 plus. Here we have removed one electron. Here bond order of N2 is 3 and bond order of this is 2.5 because the electron is removed from bonding molecular orbital. So, here bond order is decreasing. Next case, here N2 is a 14 electron system, therefore, its bond order is 3. If you remove one electron, it becomes N2 plus, and this electron is lost from bonding molecular orbital, therefore, bond order decreases by half unit, that is it becomes 2.5. So, here when N2 becomes N2 plus, bond order decreases. Now, the third case, C bit, H2 becomes H2 plus. Here bond order of H2 is 1, bond order of H2 plus is half. So, here also there is a decrease in bond order. D H2, in this case electron is lost, but this time electron is being gained, H2 picks up one electron, becomes H2 minus, and here bond order is 1 and here bond order is again half. So, here also bond order is decreasing. You can realize these are two complementary cases. In one case you are adding electron, in another case you are removing electron. In both the cases bond order is decreasing to the same extent. The reason is here you are removing electron from bonding molecular orbital, that is why bond order is decreasing, and here you are adding electron to anti-bonding molecular orbital, that is the reason why bond order is decreasing. So, bond order decreases under two conditions: when electron is added to anti-bonding molecular orbital or when electron is removed from bonding molecular orbital. So, the correct answer therefore has to be B, C, D, third option B, C, D. In these three cases bond order decreases. Question number 44. Match the list 1 with list 2. The molecules given in list 1 are A N2O, B F2O, C BF4 minus, D CH3 plus, and this side you have geometries of the particles: pyramidal, tetrahedral, planar, triangular, linear and angular. You know, N2O has a linear shape. This is one of the canonical forms of N2O, it is linear. Then the next molecule F2O, here oxygen is the central atom and two fluorines are the surrounding atoms, and it has got two lone pairs, so it is angular. Then you have BF4 minus. BF4 minus will be tetrahedral. It is tetrahedral because there are no lone pairs, 4 bond pairs are there, and that is the reason why it is tetrahedral. And then you have CH3 plus. CH3 plus is plain triangular. Trigonal planar, or you can call it planar triangular. So, the correct answer is first option. A, that is N2O, is matched with linear, that is fourth bit, and then F2O is angular, BF4 minus is tetrahedral, and CH3 plus is planar triangular. Question number 45. Here also it is a matching type of question. I3 plus, I3 minus, ICl4 minus and XeF6, and you need to match with appropriate hybridization given in the list 2. First of all, let us try to find out about I3 plus. Here we consider one of the iodines as central atom and find out the number of electron pairs, and half V is 7 plus 2 surrounding iodine atoms. One of them you take it as central atom and the remaining 2 you take it as surrounding atoms, and deduct 1 for the positive charge and you get P equals to 4. So, the hybridization can be therefore taken as sp3. Now, the next case, this is A, the next case B is I3 minus. Here also you take one of the iodines as central atom and take the other 2 as surrounding atoms, 7 plus 2 plus 1 this time. So, P equals to 5. That makes it sp3d hybridization. So, when you have 5 electron pairs, you take it as sp3d hybridization. Now, C is ICl4 minus. Here also you take iodine as a central atom and then consider the 4 chlorines as surrounding atoms, 7 plus 4 at 1, and that comes to 6, and this is taken as sp3d2 hybridization. Now, the last one D, that is XeF6, xenon hexafluoride. Apply the same formula, P equals to half into 8 this time, because number of valence electrons in xenon are 8 plus 6 surrounding atoms, it comes to 7. You take it as sp3 d3 hybridization. So, the correct answer for this question is second option. A is sp3, B is sp3d, C is sp3d2 and D is sp3d3. Question number 46. Which one of the following has maximum dipole moment? Look at the options. The first option is this is a trichlorobenzene. You can call it as 1,2,4 trichlorobenzene. These two chlorines cancel out each other, and the resultant is due to one of the chlorines, this one. Then look at the second option. Second option is this. Here there is no cancellation, and number 3, they cannot cancel each other. They are not at 180 degrees dihedral angle. Look at the third option. These 3 chlorines can cancel out each other. They are at 120 degrees dihedral angle and they cancel out each other. Mu r equals to 0. So, obviously, this is not the answer. And the fourth one is para 1,2-dichloro benzene. These two chlorines cancel out each other. Mu r equals to 0. Now, here the pulling is due to 3 chlorines. So, there is a greater extent of pulling. Therefore, the correct answer is second option. Here the 2 chlorines, unlike this case, the 2 chlorines here cancel out each other, whereas there will be effect of all the 3 chlorines towards polarity of the molecule. So, correct answer is second option. Question number 47. Here 2 lists are given. In the list 1 we have ionic compounds, and in the list 2 there are values of lattice energies. We need to match a particular compound with appropriate value of its lattice energy. It is just a matter of comparison. We need not remember the actual value of lattice energy of any compound. We need to just match on the basis of order in which you can expect these compounds to have lattice energies. See, among these compounds, magnesium oxide is reasonably ionic and it has highest charge density on cation and anion. So, magnesium oxide is expected to have highest lattice energy. So, minus 3932 can be assigned to magnesium oxide, and the lowest value can be assigned to sodium chloride. The second highest will go to beryllium oxide due to high charge densities, and then calcium chloride will get the third highest. So, the correct answer therefore will be fourth option, A4, that is sodium chloride is matched with minus 758, the lowest value, and magnesium oxide, that is C, is matched with the highest value, minus 3932. So, the correct answer therefore is fourth option. That is all about multiple choice questions on chemical bonding and molecular structure. Thank you.